First thing, Android components. So for our penetration testing thing, we'll need mainly 4 components. Like we should know these 4 main components. One is activity, second is broadcast receiver, then we have content providers, and then services. So activity basically it's a screen, so a screen which will allow the user to interact. So basically it's the UI. I'll just show you an example. So suppose have this vulnerable app called AndroGoat. So I just start this app. So this first screen you see is the splash activity. So it itself is an activity. Now this is the another main activity. And if you can see, I am able to interact with it, right? I can click buttons. I can navigate to another activity. So this thing is called the activity, the screen which you are able to see here. Next thing, broadcast receiver. So broadcast receiver is mainly, it's a component which responses to the system-wide broadcast announcements, like suppose the battery is low, like so on. Next up, we have content provider. So content provider basically, you can understand it as, if some other app, some external app requires some data, so content provider will send that data to an external app using some tables, like table form of data. And last up, we have services. So services is like, there's no such UI for services. It's just long-term processes running in the background, like we play music. So it's a service. Next up, so the types of analysis we perform during this pen testing process. So first up, we have static analysis, then dynamic, and then network. Any one of you have any idea about these and would like to share?
Yeah, like it's in static analysis, I think we could analyze when any application is not running. In dynamic, when it's running, we analyze the application. And about network, I don't know. I don't remember. Sorry.
No, you are almost correct. So for static analysis, we basically do the source code review. We don't interact with the application, like we don't run it. We just go through the source code. We find some hidden secrets. We can find API keys, or we can find the Firebase URL, which might expose some data. We can look for information disclosure bugs, like, there may be logging enabled and the application might log some sensitive data, so we can check that. And for this thing, we have tools. We can use MobSF. Basically, it's for automation. We just upload the file in MobSF, and then it will give us the static analysis report. We also have Quark. It is a good tool. It, after scanning, it will give us some suggestions on how to exploit the vulnerabilities we have found in. Next up, we have dynamic analysis. So as you mentioned, so we test the application during runtime. Like when the application is running, we'll test for some bugs. As we read about components, we'll be able to exploit these components. How? Suppose any activity or broadcast receiver is exported, it has no protection. So we can try accessing it. We can bypass the login and directly, get access to that component. Either it can be activity or a content provider. And in many cases, these activities or content providers, they have some sensitive data which we can have access to without even logging. We can just bypass the login screen and we can just directly get access to that sensitive data. And we can do this by using tool. My favorite tool is Drozer. Also, there are other tools. You can surely explore those. So yeah, so we can use Drozer to do that. And also in MobSF, we have this option for dynamic analysis also. So yeah, you can use MobSF as well if you want to go for automation. So, network analysis. So we find vulnerabilities related to network. So in case the application has insecure communication, it is transferring data insecurely, which is not encrypted maybe. We analyze the HTTP traffic, And again, we can use the tool MobSF, and we can also use burp. We can intercept the requests coming in, and then we can analyze these requests. So I have a report from MobSF. I'll just give you guys a look about it. So I scanned the tool Androgoat on MobSF, and the results were something like this. So see, there were total 25 activities, and one of them is exported. So while doing dynamic analysis, we can try exploiting these exported components, either this activity, service, or receiver. See, there are no exported content providers as such. Other than that, if you see, MobSF can give you some security analysis in which there's network and there's manifest. So there's a manifest file, there's a XML file which has permissions in it in the Android source code. So we can have a look at that and we can get to know if there's backup enabled or is the application debuggable, etc. Then there's malware analysis. So we can get any malware domains or anything of such is included in the application. And the best part is the reconnaissance part, which is automated for you. So you can find any hard-coded strings or any emails. See here, for this, as this is a vulnerable app, so when I scanned it, I got this, Firebase URL. So when I visited it, there was a password, a username and password disclosed. So as I talked about before, like, you can get some sensitive information from the databases if they are exposed. So this is how it will help you to analyze. There's also a network security part. So you can get some vulnerabilities related to network. You can go deep into it. You can read about it later. Yeah. So yeah, so as someone asked before, like he faced problems with Genymotion, right? So we have some other emulators. Personally, I use AVD. It's Android Virtual Device. So what you can do is you can just download this Android Studio from Google, and then you have this, manager here. So you can create your own device of your own choices with your own choice of API levels. And then I created this app. It's basically Android 10. So I use this one for testing the applications. So yeah, so even I like AVD better than Genymotion because I didn't have such a good experience with Genymotion. Or you can plug in your real Android device if you want to, and then you can install the tools on that, and then you can test the applications. So next up, the main topic, SSL pinning. So what is SSL pinning? Okay, so anyone have any idea about it before me explaining it if you want to share anything? Okay,
Actually, I think
yeah.
SSL pinning, where we just pin the like hard-coded certificate, unpin the hard-coded certificate which is installed in the device, so that we can just intercept the request with the burp suite.
Okay, so this is SSL unpinning. I'm talking
Yeah,
about if you know anything about SSL pinning. What is SSL pinning?
SSL pinning, I think, which is a certificate which is pinned hard-coded in the device, so that we can't intercept the request or all that things. I think this is
Yeah, yeah, you're very close. So basically, SSL pinning. So developers implement this SSL pinning just to, prevent man-in-the-middle attacks. So the application with SSL pinning won't trust any custom certificates, and it won't allow any proxy to intercept the application's traffic. So this is all just to, so that we like pentesters like us couldn't intercept anything in proxy tools like burp or OWASP zap. So that's all about SSL pinning. And let's see this in action. So, first what I'll do is I'll just set up burp, and then I'll try to intercept the requests using burp suite. So here I have the burp suite. I'll go in proxy, then in options, and I'll just add a proxy. So here I'm, since 8080 port is already occupied for web, I'll just take 8081. And let me do it for all interfaces. Yeah, and I'll just press OK. And then you have to click here. So basically we will be intercepting traffic from all interfaces which have port 8081. Now what you can do is you will first need to get the burp certificate here. So we'll get the burp certificate. Just a second. Yeah, so what I'll do is I'll navigate to HTTP burp. Sorry, I mistyped it. Yeah, so here you can click on CA certificate. It will be downloaded. Okay, you have to save the file, but then make sure this extension is DER. But for mobile phones, like when we input the, like when we put the certificate, burp certificate in our mobile phones, so the extension should be CER. So after you save the file, you can just rename it and then change the extension to CER instead of DER. I've already done it. So so here is the burp certificate. I already saved it before. So what I'll do is I'll just drag and drop it in here in my mobile phone. So it gets saved and you can navigate to files. Here you have the mobile certificate which we saved. So what you have to do, just double click on it. You can give any name to the certificate. Make sure that this credential use is set to VPN and apps, and then you can just press OK. I've already done it, so I'm not doing it again. Then you can press this 3 dots. You can go to settings. Here you have this option proxy and just set any host, like I am using localhost and the port which we set before in burp, that is 8081, and then you can just apply the proxy. So basically the proxy, we have applied the burp proxy now, so we can just try intercepting the requests now.
Is anyone trying to ask?
So this is the challenge in this Androcode vulnerable application. So, we have to first try intercepting the HTTP and HTTPS traffic, and then we have to, bypass certificate pinning. So let's just try these. So if I click on, I'll just close Firefox because it's intercepting traffic from there also. Yeah. So if I click on HTTP, see, the request is sent to demo.testfire.net. And since we have configured burp in our mobile phone, we are able to intercept the requests coming from the application. So I'll just forward it. And similarly, I'll be able to intercept the traffic for the second challenge as well. But then if you see, if I try clicking on certificate pinning, I'm not getting anything in burp. Why? Because there's SSL pinning in place. So, even if I configure burp and I try uh, intercepting the requests coming from the application, I won't be able to intercept anything because there's SSL pinning in place. And if you see the dashboard, you can see errors which shows, which means that there's some issue while intercepting the request from the application. So this is all because of the SSL pinning in place. So now let's see how can we bypass the SSL pinning and try intercepting the requests. So there are, I have taken 3 methods for this talk. So first one is using Frida. Second one is using objection, and third one is using exposed framework. So before that, I just want you to get introduced to ADB. So basically, Android Debug Bridge allows us to us here in the sense our laptop, our computer, allows it to communicate with the emulator or the device we have attached to our laptop. And yeah, here you can download it using ADB. Here is the link. You can just go follow it, and you can download Android Studio from here. And here are some basic commands of ADB. I'll just show you so it gets more clear to you. So how you can get ADB is you can just Google platform tools. You can install platform tools. You can add them an environment variable so that it's accessible from everywhere on your machine. So here I have installed platform tools, and with this comes ADB. So the first command is ADB connect. So since I have this emulator and I've already connected the device, like the device is already connected, I need not to do it again. So you can get this IP address by navigating, to the settings to Wi-Fi, and there you will get the device IP address. So the second command is to display all the attached devices or emulators. So I'll just type in ADB devices, and here is it visible or should I zoom it out a little bit?
It's visible.
Okay. So see, I typed in ADB devices, so basically it shows all the devices which are connected. So here we have this emulator device, which is our AVD, and then another command is ADB help. So basically you can list out what all other commands we can use. Again, there's ADB server, so if you want to, start it, so you can use ADB start server. If you want to kill the server and then restart it again, so you can use ADB kill server. Now ADB shell. So what this does is, I'll just type in ADB shell. So we are now in the local storage of the device, and if I do ls, you can see different directories here. We have SD card, which is the external storage of our application. We have storage and different, these directories we have here. We have metadata, etc. So basically now we are in the, we can interact with the local storage of the application. So in the static analysis part, we saw we can find some, hidden database files, or we can look for hidden secrets, we can view logcat, so we can do all these things using ADB. You can go do some research on it, how can you interact, and you can go view all the other commands on this link here. So first up, Frida. So let's see how we can bypass SSL pinning using Frida. So as mentioned, Frida is a tool which can be used to inject JavaScript snippets to the application, which will help us bypass the SSL pinning. And we can also bypass root detection. You can go learn about root detection, and I'll show you how can we bypass root detection using Frida. So what you can do is, there's a simple installation. So you can just run the command pips install Frida tools, and Frida will be installed on your machine. And suppose if you want to know the architecture of your Android device, so you can just run this command. So mine is this one. So this is how I get the architecture of my device. Why this is needed? Because, to run Frida, like to run this, we need Frida server on our Android phone. So we'll have to download the Frida server. You can download the Frida server from the GitHub page. So see, this is the Frida server. Mine will be this one because I just checked the architecture. You can check the architecture of your own phone, and then you can download it, extract it, and next you'll have to push the Frida server to the to this location in the Android. So how we used ADB to get connected to the local storage. So this is how you can push it. I'll just show it to you. Okay, so what I did, since for me ADB is not accessible from everywhere in my machine. So I just put Frida server here, and I'm running command prompt. I'll just copy paste this. So the command is something like adb push. So sorry.
Using the root clock, we can detect Ssl Pinning. Root clock.
Yeah, that's another tool. Yeah. Yeah, so this push command is basically used to push something from our machine to the Android storage, or we can take something from there to our machine. So push is something like push and pull. These are the two commands we can use. So I'll just push the Frida server, and here in Android Studio, we have this functionality to run this terminal. So I'll just do Adb Shell, and then I'll navigate to that directory where we push the Frida server. So it's data, local. If I do a ls, you can see that we have this Frida server here. So what we have to do is we have to run this Frida server. But before that, we have to change the mode so that we can execute it, we can run it. After doing, after pushing, you can just run this command to change the mode, and then just run the Frida server. I have got this permission denied error. I'll just try to run ADB as root. Okay, it's already running as root. Let's do Adb Shell again. Yeah, I'll just try to.
You can try with giving chmod 755 permissions. After that, you can try.
Actually, this Frida server file which you see right now was already there, but yeah, I'll try again. Okay, it works now. Thanks, man. So yeah, so now we have the Frida server running, and now we can try bypassing Ssl pinning. So here, there's a command called Frida PSU. So every application on an Android has a package name. So we need to find the package name of our application. So what we'll do is we can run this command, Frida ps-u. What this will do is this will just, see, it has just listed all the processes which was running. We have this entrogot running, and this is a way to find the package name. Now I know another way that is using ADB. So this is a command, ADB shell packages. So it has also listed all the packages which our Android phone has running. So now see, it's very nasty, like how do we find ours, which like our application's package name. So what we can do is we can use the find string command, and I'll just type your code. Yeah, so I have got the package name for my application, which is ovas.set.a code. So what next? See, so this is the main command. So we are using Frida. This is -u for USB device. Then this is -l. So we'll just put in our payload here, like the script which we has, the JavaScript file we'll put in here, which we'll use to bypass SSL pinning. So, and the next is -f. So this will be a package name of the application and no pause. So let's just try this. So here you can see I have 3 different SSL pinning bypass scripts, because what happens many times, like if I try with the first one, it might not work. So I need to, change the script. So this, you can do some research on these different types of scripts. You can get it from Google and then you can try these. So I'll just run the command. Let's try bypassing it. Frida -u -l SSL pinning bypass.js. Then we have our package name, which was os.set.a code. And okay, so I have run the command. Now let's see if we are able to intercept the requests. We are still not able to intercept the request. This can be the reason, because the script we ran might not have worked. We still see this error. This means that there's certificate pinning and we are not able to intercept the request. So let's try with different script. Maybe that would work for us. So the I have named it as SSL pinning bypass 1. Okay. Let's see if this one works for us. So I guess this has worked fine. Yeah, so now let's try intercepting the request. Well, now we are able to intercept the request successfully. That means we have bypassed the SSL pinning in place. So this was one method using Frida scripts. Let's jump off to the second method.
Can you show us the
So
bytes
second
where?
one is.
Excuse me, I'm sorry.
Sorry.
I'm sorry. I have a question.
Yeah.
So,
Yeah.
can you show us the bytes where you are changing the logic to be true to load in any external certificate?
Basically, bytes as in like, what do you want to say? I didn't get you properly.
So, you're loading a script, right? SSL pinning bypass.
Yeah.
So, what it changes logic of trusting Flutter's default certificate, right, to true. So, just wanted to know where you're loading it in memory.
Okay, so these are the different scripts, so you can go through those and you can know the logic. Actually, there's a shortage of time, so I don't want to go too deep into it. So when you go through the scripts, you will know the logic and everything. So you can search the scripts on Google and you can go through those.
I think for that you can decompile the APK, and for that, like for any JDX tool or any tool, you can decompile the
Yeah.
APK, and for that you can check like which which SSL pinning has been implemented, like OKSTTP or all that thing. So you will check that there is a file containing OKSTTP in the when you open this APK from JDX. Then you can go through the the whole code which has been implemented for SSL pairing. There you can find the which checklist has been which is going to be true or false, like that. For that, the checklist you are talking about. So for that you have decompiled the APK from the that you can find.
No. I'm sorry. I think I might be prolonging this. You can continue.
So it's okay. You can ask. So what you wanted to know is, you want to see the code. Is that what you are saying?
No, actually, Frida is a runtime orchestration tool, right? So what it's doing right now is, by default, Android Kotlin, it trusts its own certificate. So that is the
Correct.
reason why we can't intercept burp requests. So
Correct.
by doing this, we are finding the exact memory inside runtime, and we are
Okay.
changing that logic to be true. So for the recent versions, I was saying it wasn't successful. So just wanted to know in the script where you are
How
loading the bytes.
exactly? What makes it work? That's what you want to know, right?
Yeah, the location of bytes in the
I
script.
I think we ourselves haven't done that research, so it's going to take some time. So that answer is not ready right now, but we'll have to go through it and analyze it. So the script, what Shreyal is showing, she has just taken it. So as she mentioned, it's available on the Google. There are many scripts you can pick and try whichever works for you,
Yeah.
right? So specifically, we haven't explored, we haven't taken a look at the code and tried to understand at this point of time that what makes it work.
Oh, thank you.
Thank you.
Any other questions, guys? Okay, so I'll move forward. So the second one is objection. So as mentioned, objection is a mobile exploration toolkit that uses Frida and automates the injection process. So it is much more simpler to use. We don't have to look for any scripts or anything. We can just run objection and then we can run this command Android SSL pinning bypass disable and everything will be done automatically for us. Let's try this one. Um, yeah. So this is our app. I'll just close that script which was running before. Okay. So let's use objection this time. So the command for objection, oh, there it is. So objection -g. So after -g, we'll inject, we'll put in the package name for our application, and basically objection helps us explore. So let's put in this command. -g, and then the package name.
What is this? Yeah.
Okay. So to bypass the SSL pinning, we have the command Android SSL pinning disable. Okay. So now let me try to intercept the request again. Able to intercept the request basically. So objection has done our work a lot easier. It has used Frida and it has automated the whole process. So we don't have to inject a script using Frida and do all that stuff. So I mentioned the third one, exposed framework. So I would like you guys to do some research on it and find some other ways also to bypass SSL pinning. And if you get something new, you can share it with me also. Uh, so that's it for this stuff. Thank you for listening. And in case any questions, you can ask me.